Good morning, learners. I'm Mr. Ngakane from Naledi Yabo Secondary School in Lil-Jolepuzwa District. Today I am going to discuss with you sequences and series. Now, before I start with the actual sequences and series, I would like us to go back to where we started with this in grade 10, where we called them linear number patterns. You will recall that in grade 10, we dealt with linear number patterns. Now, with linear number patterns, if, for instance, you are given the pattern 1, 3, 5, and so on, and they say to you, write down the next two terms, for instance, what you will do is you will look at the pattern itself, whether the pattern is obvious or not. Now, when you look at this number pattern that I have, you will realize that if you say here 3 minus 1, it gives you 2, and 5 minus 3 also give you 2, which means we have what we call a constant difference. Now, to determine the next two terms, yours will just be to add the common difference to the first term. Say, for instance, 1 plus 2 will give us 3, 3 plus 2 will give us 5, and to find the next two terms, you will say here 5 plus 2 is how much? Is 7, and that will be a term after 5, a 7, and then 7 plus 2, it will give you a 9. So this is a linear number pattern. And in grade 10, we were also introduced to the general term that we use for the linear number patterns. Now, the constant difference that we just found here, the two that we found here, will actually, if we have to find the general term, be substituted in the place of B, meaning we will have here Tn equals 2n plus C. We write 2 in the place of B. Now, for us to find the value of C, we can choose any term that we like here, preferably the first term. Now, I want you to be aware that I have written 1 in the place of n, which means when I come to the right hand side, I will have 2 into 1 in the place of n plus C. But then T1 means the first term. We go back to our number pattern, then we locate the first term, and we find that our first term is actually equal to 1, which means in the place of T1, we will write 1, which is equal to 2 multiplied by 1, and that will give us 2, and then plus C. And then to make C the subject, we take this 2 to the left hand side, then we'll have 1 minus 2, which will give us negative 1, meaning the value of C here is equal to negative 1. And therefore, the general term for this linear pattern will be 2n minus 1. Now, this makes it easy for us. For instance, if they say to us, find T100 or term number 100, all that you will do is you will just put 100 in the place of n, and you will have 2 into 100 minus 1, and 2 multiplied by 100 will give us 200 minus 1, and this will give us 199. So this is what we learned in grade 10. But now, when we get to grade 12, we now change the term. We call this arithmetic. We call this arithmetic sequences. We call this arithmetic sequence, and we deal with arithmetic sequences and series. And we are also going to look at geometric sequences. Now, let's take the same number pattern. It's 1, 3, 5, 7, 9, up to the nth term. Now, when you look at this pattern here, 1 is what we call the first term. In other words, T1 is equal to 1. And then term number 2, T2, will be equal to, remember from the previous exercise, we said b here is equal to 2, and this 2 here is the common difference. So which means the second term will be the first term plus 2, which is equal to 3, which is the second term here. And the third term will be equal to 1 plus 2 plus another common difference. And this will give us the third term, which is equal to 5. And we do the same with term number 4. It will be 1 plus 2 plus 2 plus 2, and this here will give us 7. Now, looking at this, we can continue this sequence up to the nth term. We can continue this up to the nth term. But before we get there, let us look at this. In arithmetic sequences, we use A to denote T1. We say T1 is equal to A. And then we say T2 will be equal to A plus D. D represents the common difference. And then T3, when we follow this sequence, look at this, we have T2 is equal to A plus D, and then T3 is equal to A, we follow what we've done here, plus D plus D. And then the fourth term will then become A plus D plus D plus D. And this here will still remain A plus D. Then when we get to T3, D plus D is actually equal to 2D. And then with the fourth term here, D plus D plus D will give us 3D. And if we continue that up to the nth term, it means we will have A. The first term will always be there. But now, before we get to this one, I want us to look at the term number and the coefficient of D. Look at the term number and the coefficient of D. Term number and the coefficient of D, because the coefficient here is 1. You will realize that the difference between 4 and 3 is actually 1. In other words, if we were to write this T4 differently, we would say A plus the term number, which is 4, minus 1. And then we put this inside the brackets, and then you have D. Obviously, this 4 minus 1 will give us 3. And that is why I'm saying it will take us back to this 3D here. Now, 4 is in the place of a term number. So in arithmetic sequences, we use n to denote the number of terms, which means it will be, in this case, A plus, in the place of this 4, which was for term 4. Because we do not know the actual term number here, we will simply write n and then minus 1 and then D. So this here will give us what we call the general term of an arithmetic sequence.